Alright, let's come back to our DC machine polymer module. We now move on to the DC machine, the second application of DC machine, which is to work as a motor. Remember we say that most of the time the things that we use at home are motors instead of generators. Generator, in fact, we don't have it at all at home actually. Mainly like the elevators, the handrail, the washing machine, the fan, they are all motors. So now we are going to talk about the working principle of a motor. Now if you were to recall what we said about how a motor works based on electromagnetism, is that I need to have magnetic flux, right? Magnetic flux to react with electricity, a current carrying conductor to produce motion. Just like what this diagram illustrate to you. I have a pair of permanent magnets, so I have this magnetic flux, and then I have this conductor and I supply EMF to it. In other words, now the current passing through the conductor. So this current carrying conductor experienced with the magnetic flux will produce a force. It will jump inside according to the left hand rule. So that is the working principle of a motor. Right. Now, in our syllabus here, we want to analyze three types of DC motor. The first one is separately excited DC motor, DC shunt motor, and DC series motor. Okay. Once we go through the first one, you kind of like you find it easier and easier as we move on to other types. Alright. Let's zoom into our motor here first. If I want my motor to turn faster, for example, what can I do? Do you think if I supply more current, it will do the trick? Yes. How about if I make my magnet stronger? Yes. What if I have more number of conductors? Yes. So all these will improve the speed or increase the speed of the rotation of the motor. Okay. So now with these three, we will now zoom into the first one. Yeah, separately excited DC motor. Right, don't get confused with separately excited DC generator, which was the circuit that we learned before. But now we're now doing motor. So this is the diagram. Now if you look at this diagram, can you roughly tell what is the difference of this versus a separately excited generator? The difference, of course, now there is a power supply. There's a supply voltage here. Whereas the generator, we drew the armature over this side. Remember, this side was the load. Okay. So a separately excited DC motor, you will have a supply voltage, there's supply current to your generator, the conductor here. Remember the current carrying conductor, alright? And this is the armature winding resistance, the resistance of the armature wire here. And this motor is going to generate motion, so we draw a fan plate to represent motion. Okay, and this is the magnetic circuit: VF, IF, RF, field voltage, field current, and the field winding resistance. Now, across the armature, it's supposed to turn to become a motor for you, right? But inevitably, a voltage is also induced. And this voltage is called the back EMF. EB is called back EMF. In other words, even though it is working as a motor, but because of the law of electromagnetism, it is current carrying, the conductor is moving, is rotating, and it reacts with the magnetic flux. It also produces an EMF inevitably. And this EMF, we call it EB or back EMF. Back EMF. Alright? Okay, so let's analyze this circuit. I have here 250 volt, 60 ampere, 0.15 ohm, and the motor is running at a speed of 927 revolution per minute. Okay, let us learn how to calculate EB. Okay, if we were to use KVL, Kirchhoff's voltage law, right? By using KVL, we would write VS equal to IARA plus EB. Yes or no? VS equal to this voltage plus this voltage. So therefore, EB is equal to VS minus IARA. And my VS is 250 minus 60 ampere multiplies 0.15. Right? And if you were to use calculator to calculate this value, you'll find that EB is therefore equal to, alright, let me try using my calculator. 250 minus 60 times 0.15. So that's 241 volt. Okay, so that's how we calculate EB. The next thing we want to do is to find the power developed. Okay, power developed. Alright, the power developed in the motor. Okay, and again we use V times I. This is your motor. So the V is EB and I will be IA. So it's 241 multiply 60. Right, so 241 multiply 60. So that gives me 14460 watt. So that is power developed. Okay, how to find EB? KVL. How to find the power developed? Using the formula V times I. Alright, now the next thing that I want to introduce to you is about rotational loss and the output power. Now if I were to say the rotational loss, rotational loss is about the power loss. Now as the motor is moving, noise is being generated, friction is being generated, right? So there's this rotational loss. In other words, they are not useful power, they're being wasted in this way, like I explained to you, the noise generation, the friction. Yeah. So if I give you that the rotational loss is equal to 150 watt, for example, or I say it's 200 watt, okay, then the output power will be equal to the developed power minus the rotational loss. The motor has developed 14460 watt. 14460 watt. Okay, and due to the losses of 200 watts, we call them the rotational loss. So I have the real output power is 14260 watt. So this is the real useful power, the mechanical power, the output power. Right? And with that, we can talk about the efficiency. Now, efficiency is always described or calculated output divided by input times 100%. Output divided by input times 100%. So for this separately, for this example of separately excited generator, right? My developed power is 14460, my rotational loss 200, so my output power is 14260. So it's 14260. Okay? What is my input power? If you look at this circuit here, in order for the motor to work, I must have two circuits to work, right? So the supply power to these two circuits is one is Vs times Ia. The next one will be Vf and If. Because without the two circuits, the power motor will not move, right? So these are the input power. Right, so if I were to do my calculation is 14260 divided by 250 times 60 plus my Vf versus If. So if I were to give 200 volt and I say that this is equal to 15 ampere, for example, yeah, then it's 200 times 15. So that will give me the efficiency value of this separately excited DC motor. Okay, right, before I move on, can I do a summary of this separately excited DC motor? What is the function of this circuit here? This is your magnetic circuit. Remember the electromagnet, responsible to produce the magnetic flux. And this is called the armature circuit, right? And the whole thing is called separately excited DC motor. The Vs supply the current to your conductor. So the current carrying conductor react with the magnetic flux to produce motion. Okay, first, how to calculate EB, right? Using Kirchhoff's voltage law, EB is equal to Vs minus IaRa, right? Vs minus IaRa give you EB. How to calculate the power developed by the motor? V times I is EB times Ia, EB times Ia. Okay, and how do I calculate the output power? Is the developed power minus the losses, which we call them the rotational loss, right? The value will be given. And how do we calculate the efficiency? efficiency is equal to output divided by input times 100%. Okay, so that is the separately excited DC motor. Now the next mathematics that we'll go into it here is to calculate the torque, T-O-R-Q-U-E. Now torque developed. Torque developed is actually a force, a circular force, a twisting force. And if we know the power developed, we can find the torque of this motor, right? Torque is equal to 60 divided by 2 pi n multiply power developed, right? So the formula is 60 divided by 2 pi n is the speed. So I have the speed given to you is 927 RPM, right? Multiply the power developed that I calculated just now, which is the EBIA. I've forgotten the value, but we have already calculated it, right? So the answers is the torque, the unit for torque is Newton meters, and that is the formula for torque. Okay, separately excited DC motor. Maybe you can then tell me, how do I calculate power developed? EB multiply IA, very good. How do I calculate the output power? Power developed minus the rotational loss. How do I calculate torque? The formula is torque is equal to 60 over 2 pi n multiply power developed. What is the unit for torque? Newton meters. Alright, so that is all about separately excited DC motor. Thank you.